Welcome to math classes. In continuation with the sets, relations and functions series, this is the part 3 of the video. Okay. So as you know, this is NCERT book unit 1 and 2. Okay. Sets, relations and functions. And this is good for class 11th, 12th, JEE, BITSAT and engineering entrance students. Okay. Let's get into the critical problems. Continue with the previous videos. Okay. So this is JEE question. There is a function defined f, okay, r minus 3 without 3 from r minus 3 to r minus 1. Okay, this is defined as f of, and f of x is defined as x minus 2 divided by x minus 3. Okay, and its domain is r minus 3, range is r minus 1. Okay, now another function g defined from r to r. Okay, and its definition is g of x equal to 2x minus 3. Then sum of all values of x such that f inverse x plus g inverse x equal to 13 by 2. We haven't learned the inverse problems yet actually, but this is very simple. Inverse is not very complex with respect to the functions definitions. Okay, so how to find inverse of a given function? This is what we will learn mainly in this question. Okay, we need to find inverse of a function of f of x and g of x. That is the key. Once you know how to find this inverse, the problem is very simple. Okay, f of x is given as x minus 2 by x minus 3. So let's call this as y. Okay, whenever you want to find inverse of a function, you equate it to some other variable and then find x in terms of that variable. Okay, in this case, we will find x in terms of y. That is the inverse function. Okay, so you take y to the, x minus 3 to the other side. So y into x minus 3 equal to x minus 2 or y of x minus x equal to 3y minus 2. Okay, you simplify further, what you will get is x is equal to 3y minus 2 divided by y minus 1. So this is what y is nothing but f inverse of x, right? So if I put f inverse of x is nothing but 3x minus 2, okay, 3x minus 2 divided by x minus 1. This is my inverse function. Okay, similarly, I will find the inverse function for the g of x. G of x equal to 2x minus 3, let it be y, which implies x is equal to y plus 3 by 2. So my g inverse of x is equal to x plus 3 by 2. Now it is given that f inverse of x plus g inverse of x is equal to 13 by 2. So I take the LCM, simplify it. You will get a quadratic equation 2x square minus 10x plus 12 equal to 0, or simplify it to x square minus 5x plus 6 equal to 0, which means x has two roots, right? 2 and 3. These are the all possible values of x. Correct? This is what we are looking at. So sum of these values is x equal 2 plus 3. That's the sum of the values, which is 5. That's the answer. Okay, so hope you understand how to find out the inverse function from this question. This is a JEE question. So once you know the technique, questions are simple. Okay, at least as I every time say, more than 50% of the questions are straightforward and simple. Don't do mistakes. That's all. Next. Okay, f of x equal to x square minus x plus 1. Then what is the value of f of 0? This is another type of problem which keep coming in engineering entrance exams. Okay, how to find such things? Okay, now we need to find f of 0 now. Okay, from this, if I substitute x equal to 0, I'll get f of 0. I'll get it. Okay, but not f of 0. So from this, how to get f of 0? So let's how to do these such problems. First, take simple numbers 0 and 1. If required, maybe 2 and 3. Okay, and then find out what is the value of f of that number, and then simplify further from there. Okay, so in this case, I'll take f of 0, which is equal to, if I substitute 0 in this, 0 square minus 0 plus 1, which is 1. f of 1 is equal to 1 to the power of 1 square, sorry, 1 square minus 1 plus 1, which is 1. Okay, so now I have two values, f of 0 and f of 1. Okay, now f of x is defined as x square minus x plus 1. This is given. So I am substituting x is equal to f of x. For x equal to f of x, what I will get is f of x, f of x. Okay, in the place of x, I am substituting f of x. So here also f of x square minus f of x plus 1. Okay, now why I am taking this? Okay, because I have f of 0 value. I will simply replace and get my multiple equations here. Okay, if I substitute f of 0 is equal to f of 0 square minus f of 0 plus 1, which is equal to f of 1. Why this is f of 1? Because if you see clearly, f of 0 equal to 1. So this part inside bracket, this whole part is, okay, this whole part is 1. So this is nothing but f of 1. This whole expression is f of 1. This is my equation 1. Okay. Now let's do same thing for f of 1. Okay. F of 1, which is equal to f of 1 square minus f of 1 plus 1, which is equal to f of 1 again. Why? Because this is also 1. Correct? F of 1 is 1. So this is also 1. So which is equal to f of 1. So I can take f of 1 to the other side. It will become f of 1 square minus 2 f of 1 plus 1 equal to 0. So now this is the equation. Okay, quadratic equation in terms of f of 1. So if I simplify, what I will get? F of 1 minus 1 whole square equal to 0 or f of 1 equal to 1. This is my first value. Okay. Now next, if I substitute this f of 1 into the E1. Okay, what will happen? F of 0 square minus f of 0 plus 1 equal to f of 1, which is equal to 1, right? So 1 gets cancelled. I am left with f of 0 square minus f of 0 equal to 0, or simplify, I'll get f of 0 equal to 0 or 1. Two values are there. Only thing is, don't assume that it has two values. Okay, it's a function, right? So substitute this value and see where it fits correct. Okay, let's take f of 0 equal to 0 first. Okay, f of 0 equal to 0, then what happens? F of 0 is equal to 1, which implies, okay, if this is 0, then f of 0 equal to 1. Correct? If this is 0, then f of 0 equal to 1. Is it correct? Wrong, because I am assuming f of 0 equal to 0. I am starting from here and I am ending at f of 0 equal to 1, right? So which is not correct. This is contradictory. So take that second value, f of 0 equal to 1. Okay, this is what I am taking. Then f of 0 equal to 1, which implies this is 1, right? F of 0 equal to 1. This is my assumption. So if I take f of 0 equal to 1, then f of 1 equal to 1. F of 1 is equal to 1? Yes. We already know f of 1 is equal to 1. So this is consistent with the answers, right? F of 0 and f of 1 definitions. This is consistent. So f of 0 is equal to 1. This is my answer. Okay. Hope you understand how to do these problems for f of 0, f of 1 when you are given f of x or f of x. Okay. Similar equations. Okay. Next. This is a JEE question. Let set A is defined as n belongs to natural numbers such that HCF of n comma 45 equal to 1, which means 45 and n are co-primes. All co-primes of 45. So this is clearly a infinite set. Okay, so let's see the set B. Set B is equal to 2k such that k belongs to 1 to 100, which means it's an even number from 1 to 100, even number from 1 to 200 actually. Okay, because it's a 2k is what we need. Okay, so all 2, 4, 6, 8 up to 200. So this is a finite set. So when you look at the intersection, the elements, the sum of all elements of A intersection B. So intersection B, A intersection B is restricted by set B because A is infinite set, B is a finite set. So let's see how to do this. Okay, so first thing is what are the co-primes of 45? So you should not have multiples of 3 and 5, right? So A is a set of all co-primes of 45 and A is equal to natural numbers minus 3 multiples minus 5 multiples and add, okay, then add repetitions, okay, because you may have some 15 multiples here, okay, all those repetitions you remove, yeah, add basically, okay. So, and B is a set of even natural numbers less than 200 or, okay, A intersection B is equal to set of even natural numbers and co-primes of 45 and less than 200. Okay. So I can also say if A belongs to A intersection B, then A by 2 belongs to another set called C, where it is a set of natural numbers and co-prime with 45 and less than or equal to 100, up to 100 only, right? Okay. So this is a simple set which we can easily find out. Okay, hence sum of elements in A intersection B equal to 2 times the sum of elements in C because it is A by 2. Okay, now what is the finally it is, okay, 2 times natural numbers from 1 to 100, sum of natural numbers minus sigma of 1 to 33 3n. This is 3 multiples, and why 33? Because 33 into 3 is 99, which is less than 100, minus 1 to 25n. These are 5 multiples, okay, and 20 because 5 into 20 is 100. Okay, plus repetition here. Okay, sigma 15n, n is from 1 to 6. 6 because it is up to 90. Okay, if you take 7, it will become more than 100. So just simplify this one and then you will get the answer. That is 5264. This is the answer. Okay, next. Okay, this problem came in JEE Mains, exactly similar to the previous one. So just because it has come, I just want to give you another practice question here. Sum of all elements of set alpha belongs to 1 to 100, where HCF of alpha comma 24 equal to 1. Okay, which means it is half of the previous problem. Okay, all coprimes of 24. That's what we are looking at from 1 to 100. Okay, we'll try to do it simpler way. 24 factors are 2 and prime factors are 2 and 3. Okay, so which means A is a set of all coprimes of 24. So given set X is equal to 1 to 100 natural numbers minus 2 multiples minus odd multiples of 3, I said, because okay, I can say multiples of 3 and then add repetitions, right? So instead of that, I just took odd multiples of 3 because odd multiples of 3 does not contain even numbers. Okay, so this is a simple way. Okay, now A equal to set of natural numbers which is less than or equal to 100. So B is set of natural numbers, even natural numbers less than or equal to 100, which is 50 elements are there in set B. That is, set B is nothing but this value. Okay, two multiples. Okay, these even numbers we will have 50 numbers, and set C is nothing but 3 to 99. Okay, and these are all odd multiples of 3, so they will have a difference of 6. Correct. So it is a arithmetic progression 3 to 99 with a common difference of 6. Okay. So how many elements are there? How do you find out? Last number minus first number divided by common difference, which is 6 plus 1. So there are 17 elements in this. So now you put number of elements in the set theory. Okay, very simple. Sigma of n, okay, minus sigma of 2n, 1 to 50, and sigma of 3 into 2n minus 1, okay, which is 1 to 17. So if I simplify this, what I will get is 1633. Okay, so this is the sum of all elements of set X. Okay, next. Yeah, this is the JEE mains problem. Set A is defined as n belongs to natural numbers and n is a 3-digit number, which means n is from 101 to 999. Okay, this is a finite set. B is equal to 9k plus 2, where k belongs to natural numbers. So this is the infinite set. Okay, and C is equal to 9k plus L, where k belongs to natural numbers. This is also an infinite set. And for some L, and L is between 0 and 9, that means L has values 1, 2, 3, 4, 5, 6, 7, 8. Okay, 2 is also part of it, which is nothing but B. Okay, but it can be any one of the value. Okay, not all of the values. Okay, if the sum of all elements of set A intersection B union C is 274 cross 400, then L is equal to, what is the value of L for which A intersection B union C sum of all the elements is this value? Okay, this is what we need to find. And here very clear, C, B and C are infinite sets. When you do A intersection with that, okay, you are restricting your B and C to the 3-digit numbers. Okay, which means they are from 101 to 999. So this is our first point. That is what the A intersection B union C. Otherwise, you can just ignore A intersection and do everything on B union C. Okay, and restrict yourself sets to 101 to 999. Okay, so A intersection B union C is a set containing 3-digit numbers in the form of 9k plus L. Okay, so let us restrict calculations to 3-digit numbers. B is equal to this value. If you take k equal to 11, okay, if you take k is equal to 11, 99 plus 2, which is 101, starting with, and then you keep on adding 9 up to 992. Okay, these are all the 3-digit numbers possible with 9k plus 2. So sum of all these, not digits, sorry, sum of all elements is equal to, there are 100 elements, so 100 by 2 into 101 plus 992, which is 54,650. Definitely this is not equal to this one. This is much bigger value than this value. So there is some other L possible. Okay, so that you will define your set C, and sum of all these elements, okay, B union C will give you 274 into 400. Okay, now let's take if L equal to 2, then C is equal to B. Okay, then B union C will become just B. Okay, so number of elements in B union C will become number of elements in B only. B or C, basically both are same. Okay, so number of elements in B union C will become number of elements in sum of, basically this is sum of elements in B union C, sum of elements in B, which is 54,650. So definitely it is not correct. Okay, because given value is very big, which is 109,600. So L is not equal to 2. Now let's take some other value of L, which means B intersection C is 5. Okay. If you take any other value, B and C are distinct sets. Okay. So which means number of elements in B union C equal to number of elements in B plus number of elements in C, because intersection is 5. Okay. Which implies this total is equal to, okay, this is the total from number of elements in B plus sum of elements of C. Okay. So from this we have to calculate sum of elements of C. So sum of elements of C is equal to subtraction of this one, which is nothing but 54,950. Okay, and sum of elements of C is defined as 9k plus L from k equal to 11 to 110, restricting this value to 3-digit number. You simplify it, what you will get is 9 times 100 by 2 into 11 plus 110 plus 100 L. This is 100 L. Okay, so if you simplify this equation, what you will get is 100 L equal to 500 or L equal to 5. So that is the answer. Okay. If you take L equal to 5, the set C is defined and the sum of all the elements of B union C will give you 274 into 400. Okay. So answer is L equal to 5. Next. Okay. Yeah, this is the domain problem. Absolute value of x plus 4 plus absolute of x minus 4 equal to 2 absolute x, and absolute of x plus 1 plus absolute of 5 minus x equal to 6. Then x belongs to what? What is the domain of x? That means basically. First thing is we have to take the critical boundaries of each equation and find out what is the domain of each equation, and then union of it. Okay. So for this one, the critical numbers are minus 4 from this, 4 and 0. Okay. So I will get ranges, domain range from x equal to less than or equal to minus 4, or x is between minus 4 and 0, x is between 0 and 4, and x is greater than 4. So if I take this case 1, x is less than or equal to minus 4, definitely this will become minus x plus 4, minus x minus 4, so minus 2x and minus 2x. So both will be equal. So this is a valid domain. Okay, x is between minus 4 and 0. You take any value, x equal to minus 3. This won't get satisfied. Okay, equation won't get satisfied. So this is not a valid domain. Similarly, x equal to 0 to 4 also, you take 1 or 0 value. This equation don't get satisfied. So it's not a valid domain. X is greater than 4. So this will be positive, x plus 4, this will be positive, x minus 4. So 2x, which is equal to 2x. So this is a valid domain. So my domain from the first equation is x is less than minus 4, less than or equal to minus 4, or x is greater than or equal to 4. Okay. Now from the second equation, similarly, if I do, the critical points are minus 1 and 5. So x is less than minus 1. This is not a valid solution. You can substitute the value and see. Minus 2 you can substitute and see. Okay, this is not a valid solution. X equal to minus, between minus 1 and 5 inclusive, this equation holds good. Okay, x is greater than 5, again this is not a valid solution. You can substitute some value and see. Okay, so which means I am left with my domain from the second equation is minus 1 comma 5 inclusive. Okay, x belongs to minus 1 comma 5 inclusive. So from these two domains I can derive that my final domain for x is between 4 comma 5 inclusive. Okay. Yeah, that's the answer. Next. Let's do this JEE advanced problem. This came in 2022 JEE advanced. Very interesting problem. It could potentially come in mains now. Okay, 2025-26 onwards, you may get this in the mains. Okay, very interesting concept. F of x equal to x tan 1 plus log 123 to the base e divided by x log 1234 to the base e minus tan 1. Okay, and x is greater than 0. Least value of f of x plus f of 4 by x is what? Okay. So looking at that, if you really substitute x value with f of x, you take and substitute x with this big expression, simplify, it looks very difficult to get some reasonable answer, right? So definitely there is some trick. And when you see this f of x and f of 4 by x, okay, you should think whether it's a self-inverse function or involution function. Okay, there is a concept. Let's first learn the concept of involution function or self-inverse function, and then come back to this problem. Let us understand the concept of involution function. Okay, so involution, or it's also called self-inverse functions. Let's see what it is. Okay, a function a functional equation involves a function operating on itself, then it's called the involution function. Okay, the equation f of x equal to x is an example. Okay, if you get f of x equal to x, then it's called the involution function or self-inverse function. What is the advantages and how do you operate? Okay, let's understand it easily in a mathematical way with an example. Okay, we are applying the function twice on itself. Okay, so you took a x, applied function on it, then it is f of x, then apply again function on it f of x, which is equal to x. Okay, so for all x, then it is the involution. Example is f of x equal to 2 minus x. Okay, f of x equal to 2 minus x, then f of x will become 2 minus x, which is nothing but x. You got the x back, right? This is a involution or self inverse function. Okay, now the examples are, these are the some of the examples: f of x equal to x, f of x equal to minus x, f of x equal to 1 by x, 2 minus x. All these are involution functions examples. Okay, then the property of this one is f of x equal to x, correct? This does not give us any uh, information, but if you try to do this one, you take one of the function to the other side, then it will become inverse, correct? So f of inverse of x equal to f of x. Okay, this gives a lot of information. That means the function and the inverse function on x is same. Okay, right? So this is very useful. This very useful in solving the equations and transformations and in the cryptography. This is very useful actually. Okay, so remember that if it is the involution function, then f inverse of x equal to f of x. Okay, and how the graph looks, normally the involution function graph is symmetry about y equal to x. Okay, if you see here, this red dotted line is y equal to x, and involution function comes like this. This is example of 2 minus x, y equal to 2 minus x. It's about symmetry about y equal to x. Okay, then where do you use this? I already told you, transformational geometry. Cryptography, it is very useful, coding and decoding actually. Okay, and some physics and symmetry problems we can use this. Okay, and these are your problems to practice. You just try it yourself and see. Third one is very important. Okay, if f of x equal to ax plus b divided by cx minus a. Okay, you can see x and a here. Coefficient of x on the numerator is a, and on the denominator minus a is there without any x component. Okay, if the function is in this way, it is involution. Okay, let's try to do this. f of x will become a times ax plus b by cx minus a plus b, numerator and denominator also a c times ax plus b divided by cx minus a minus a. You simplify it and find out f of x, you will get which is we also call of x. Okay, is nothing but x. Okay, so if any equation is in this format, ax plus b divided by cx minus a, where a and minus a, this is most important, then it's a involution function. Okay, this is very useful information. We can solve several problems using this. Okay, hope you understand involution function or self-inverse functions. Thank you. Okay, coming back to the problem. Okay, now we understood that if something is in the form of ax plus b divided by cx minus a, it is the involution or self-inverse function. If you see here, tan1 is nothing but a for us. Okay, so ax and minus a in the denominator. So this is the involution function. So once you know that, this is a very simple two-line problem actually. Okay, so f of x equal to this one. This is in the form of this. It's an involution function. Correct. So f of x is equal to x. F of 4 by x equal to 4 by x. That's it. So you sum both of them. You need to get minimum value. This is, you always know. You have to apply am greater than or equal to gm inequality. That will help you because you have a x and 1 by x term, right? So f of x plus f of 4 by x is equal to this value, and you apply am greater than gm rule. Okay, this is x plus 4 by x is greater than or equal to 2 times square root of x into 4 by x, which is x gets cancelled and you will get 2 here. So x plus 4 by x, which is on the nothing but f of x plus f of 4 by x is greater than or equal to 4. So the least value of it is 4. See, the problem is so simple actually once you know the concept of involution function. Okay, hope you enjoyed this problem. Next. Yeah, this is another JEE mains problem. Very typical in its nature, and it can definitely come in any of the competitive exams. Okay, so you should know how to solve this. the number of non-empty equivalence relations on the set 1, 2, 3. Okay, so it can be 1, 2, 3. It can be A, B, C. It can be A, B, C, D, E, F. It can be any number, right? So we'll take the example of 1, 2, 3. Okay, this has come in JEE Mains 2025. Okay, so first thing is, what is the non-equivalence? Equivalence relation. It should be reflexive, symmetric, and transitive. Okay, then we need to find out non-empty sets. Okay, no empty without uh, including the empty sets. Okay, so first thing is for reflexive, A comma A should belongs to R. Symmetric, if A comma B is in the relation, then B comma A also should be in the relation. For transitive, we know if A comma B is in relation, B comma C is in relation, then A comma C also should be in the relation. This is transitive. So let's see a simplest form is this one R1, 1 comma 1, 2 comma 2, and 3 comma 3. This is definitely reflexive, this is symmetric, and this is transitive also by itself. Okay, let's take R2, which is nothing but all three I will include 1 comma 1, 2 comma 2, and 3 comma 3, and then I am including only 1 comma 2 and 2 comma 1. Okay, so that symmetric and transitive are satisfied. Okay, if 1 comma 2 is included, 1 comma 2, then 2 comma 1 is included, symmetric. So if I take 1 comma 2 and 2 comma 2 are present, and then by transitive property 1 comma 2 also should be there, which is already there. Okay, if I take 2 comma 1 and 1 comma 1, so 2 comma 1 also should be present, which is already present. So all three uh, relations are satisfied: reflexive, symmetric, and transitive. So similarly, I will take, instead of 1 comma 2, 2 comma 1, I will take other two sets, which is 1 comma 3, 3 comma 1. Okay, this is my R3, and then R4 I will take 2 comma 3 and 3 comma 2. Okay, now what is my R5? So let's consider, I'll take 1 comma 1, 2 comma 2, 3 comma 3, 1 comma 2, 2 comma 1. This is R2, nothing but, and I'm including 1 comma 3 and 3 comma 1 in this. Okay, is it a equivalence relation? This is not a equivalence relation. Why? Because you take 2 comma 1 and 1 comma 3, then 2 comma 3 also should be present in the set, right? In this relation, 2 comma 3 also should be present in this set, which is not present. So this is not a equivalence relation. Okay, transitive property is not satisfied. Okay, so this is not, definitely you cannot have only two of them, then all those combinations are not possible. You can include all three, that is possible. Okay, so my R5 is 1 comma 1, 2 comma 2, 3 comma 3, then 1 comma 2, 2 comma 1, 1 comma 3, 3 comma 1, 1 comma 2 comma 3, and 3 comma 2. All 9 elements are there. That's the maximum you'll get, right? 3 square. So this is my R5. So there are total 5 relations are possible, equivalence relations with the set 1 comma 2 comma 3. Okay, so answer is 5. But just imagine, if the set is having 1, 2, 3, 4, 5, 6, let's say, then how much time it will take you to find out how many relations are possible, and how do you get it? It becomes very complex, right? So to solve this, you need to understand the concept of Bell number or a general recursive formula. Okay, there is a general recursive formula for this, and it's called a Bell number. This will explain you about the how many number of equivalence relations are possible in a given set with number of elements. Okay, if n is the number of elements, what is the equivalence relations possible? That is, you can derive it from the Bell number. Let's understand this one. Let's understand the Bell numbers or counting non-empty equivalence relations on a set. Okay, let's understand this using the Bell numbers. This will be a easy one for you to solve the problems. Okay, equivalence relation groups elements into non-overlapping subsets. Okay, this is the key idea behind this equivalence relations. Okay, the number of ways to partition n element set is given by the Bell number Bn. Okay, if there are n elements, then Bn is the number of ways you can partition them into equivalence relations. Okay, Bell numbers are used in combinatorics, number theory, and real world applications. Okay, what is this? Let's understand. A partition, let's partition a set, okay, which is number of elements are 3 and ABC are the elements. How many ways you can partition? Okay, ABC, one set, and then A comma B one set, and C is another set. Okay, basically non-empty disjoint subsets. Okay, this is same as if it is given a set, you find a number of non-empty equivalence relations. Okay, similar way you will find. AB is one, C is one set, AC is one set, B is one set, BC is one set, A is one another set. Then ABC, all three separate. So these are the 5 possibilities possible. Okay. So B3 equal to 5, we call it Bell number basically. Bell number 3 is equal to 5. Okay. Then what is the general um, formula for bell number? This is a recursive relation. Okay. It's a recurrence relation and a recursive function will write. We know that B0 equal to 1. Okay, which is will define, and B1 equal to only one element is there. There is only one way. There are two elements. There are two ways. Okay. So the recurrence relation of Bn plus 1 is equal to sigma of, okay, sigma of nck bk. Okay. So k is equal to 0 to n. Okay. This is sum of nck's product multiplied with bk. Example for B3. Okay. If I take B3, n equal to 3. So k equal to 0 to uh, b is 3, right? So n is equal to 2. Okay. So k is from 0 to 2. 2ck or 2ck bk. Okay. So if I expand it to 2c0 b0, 2c1 b1, 2c2 b2, which is nothing but b0 is 1, b1 is 1, b2 is 2. Okay. And product is 2c0 is 1, 2c1 is 2, 2c2 is 1. So if you simplify it, you will get 5. So b3 is equal to 5. Okay. Similarly, other numbers you can find. b4 you can find from uh, b3, b2 and b1. Okay. This is the table. If you want to remember, instead of solving this every time, if you want to remember, this is the way. Okay. For n equal to 0, b0 is 1, b1 is 1, b2 is 2. Okay. b3 is 5, b4 is 15, b5 is 52. Okay. So you can just use that recurrence relation and find out the values. Otherwise, there is a bell tree actually, which is very easy to remember this one, bell tree. And this is the trick for your JEE mains or advanced. Okay. If such question comes in. Okay. For n equal to 1, it is 1. For n equal to 2, you take this 1 here. Okay. And 1 plus 1 is 2. Okay. 1 is moved here. Okay. And then 1 plus 1 is 2. Okay. Next, n equal to 3. And 2 is the answer. Okay. For n equal to 2, right? N equal to 2, Bn is 2. Okay. That's the final number. Okay. Now, for n equal to 3, you take this 2 here. 2 plus 1, 3. 3 plus 2, 5. This 5 is the answer. Okay. For n equal to 4, you take this 5 here. Okay. This is how you build the tree. 5 plus 2, 7. 7 plus 3, 10. 10 plus 5, 15. For n equal to 5, you take this 15 here. Okay. 15 plus 5, 20. 20 plus 7, 27. 27 plus 10, 37. 37 plus 15, 52. 52 is the answer. So this is how you will find out the bell number. Okay. So if a question comes with, let's say, 5 elements in the set and you want to find the number of equivalence relations with the set whose elements are 5. Okay. Then you just build this tree. Very simple. Once you know how to build the bell tree. Okay. This is how you build the bell tree. Answer is 52. So in our case, previous example, the number of elements are 3. So 5 is the answer. Okay. So applications of bell numbers of course, combinatorics and counting partitions, data clustering, it is used. Number theory, it is very much used. Set theory, this is where our problem was actually, from where we came to this theory part. Okay. So classifying equivalence relations. Okay. So it is applicable there also. Hope you understand this bell number and bell tree, how to build it. This is very important problem which is keep coming in JEE advanced and mains and other engineering entrance exams. So learn about it. Okay. So thank you. This is the very important set of JEE and other engineering entrance problems. Okay, learn them, practice more. I'll keep making more videos and new chapters. I will keep adding. Till then, do maths. Thank you.